Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating Julia package. Borrowchecker.jl. It's like Rust's Borrowchecker, but for Julia. Get ready for some serious memory safety talk, folks.
Ooh, memory safety, my favorite topic, especially when it involves macros and ownership. So what's the big deal with Borrowchecker.jl? Why not just stick with regular Julia?
Well, Julia's garbage collection is awesome, but it doesn't prevent all memory-related issues, especially in concurrent code. Borrowchecker.jl aims to bring Rust's ownership and borrowing model to Julia, helping you catch potential problems during development. Think of it as a safety net, a really sophisticated safety net.
I see. So it's like adding a layer of extra protection, a kind of memory bodyguard for your Julia code? But how does it actually work? Is it magic?
Not quite magic, but close. It uses macros like @at own, @at move, @at clone, and @at ref, to track ownership and borrowing. @at own. @at own x equals creates an owned value. If you then try to move that ownership elsewhere, like @at move y equals x the original x becomes unusable. You get an error if you try to access it. It's all about preventing those nasty data races.
That sounds pretty strict. Doesn't that limit flexibility? What about situations where you need to share data between variables?
Good point. That's where borrowing comes in. The @at ref macro lets you create references without moving ownership. You can have multiple immutable references, but only one mutable one at a time. It's all about carefully controlling access to your data. It's a bit like a library book. You can borrow it, but you have to return it before someone else can borrow it mutably.
The library book analogy. I like that. So how does it handle more complex scenarios like loops or multi-threaded code?
It has macros for loops too. @at own for and @at ref for handle ownership and borrowing within loops. And for multi-threaded code, the experimental @at managed block automatically applies borrow checking across your entire call stack. It's pretty ambitious, but also experimental, so use with caution. It uses cassette.jl to do this recursive overdubbing.
Whoa, recursive overdubbing? That sounds intense. So what are some of the potential downsides? Is it a performance hit?
Well, it's a development tool, not something you'd use in production. There might be a slight performance overhead during development, but it's a trade-off for increased safety. And, it's not a perfect system. You can still find ways to cheat the system if you really try hard enough. It relies on the programmer's cooperation.
So it's not a silver bullet, but a powerful tool for catching errors early. That's a fair trade-off. What about the API? Is it user-friendly?
The API is still under active development, so expect some changes. But the core macros are pretty straightforward. It's designed to be intuitive, mimicking Rust's syntax where possible. Plus, they've got good documentation and examples. It's definitely worth checking out if you're serious about writing safer Julia code.
Sounds promising. It seems like a valuable tool for anyone working on larger, more complex Julia projects. Thanks for the rundown.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Remember to check out the GitHub repo for Borrowchecker.jl. The link is in the show notes. Until next time, goodbye.
Bye-bye.